I have Maths Olympiads question. You know what Maths Olympiads problems are? They are challenging problem solving, competition that will enable you think outside the words box. This kind of problem is non-routine. It is unusual kind of maths questions you do. So you need to reason it out. You need to think outside the box. This is how you do it to get the solution. Now, without wasting your time, let's jump right into it. The first thing you need to do at this point is to express this 9 as 3 to the power of 2. So what I have here will be 3 raised to power 2. Then this x is what you have here, raised to power x, minus x raised to power 2, then raised to power 2, which is equal to 65. Obviously 2 times 2 is what? 4. In that power 4, I decided to multiply the two values that will give you 4. Now I want to balance the power in the sense that I want both powers to be the same, and to do that you need to recall your words, what we call commutative property. In commutative property, if you say 2 times x, it is what? 2x. If you also say x times 2, is still 2x. So in that case, they are going to swap. Okay, I'll change their positions, but it doesn't affect the outcome. I've said it earlier, 2 times x is what? 2x. X times 2 is what? 2x. So it doesn't affect the outcome. So in that case, I'm going to have 3 raised to power x, then raised to power 2, minus x raised to power 2 times power 2, which is equal to 65. Now if you observe this carefully, you see that there is something that shares what? There's something similar to what I'm having there, isn't it? I know these things are separated by what? Minus. So I can recall yes, this is being squared, this is being squared. So, and they are separated by what? Minus. So I will need to recall difference of 2 squares, isn't it? So at this point, I'll have, in your difference of 2 squares, if you have a squared minus b squared, of course you can have it to be what? A plus b times a minus b. So that is what we have here. So it does not matter. In that case, I'll have 3 to the power of x minus x squared brackets 3 to the power x plus x squared. It will be equal to, now you can see these values have been obtained through what? Difference of 2 squares. So in other words, this will have a separate value, this will have a separate what? Value, which gives you total of what? 65. So we need to reason it out. Factors of 65, 2 values, to multiply them, you get what? 65. In most cases, inspections can also help to get this solution. So I can think of maybe 5 times 13 or 13 times 5 commutatively. But here I have minus. When you subtract, values tend to reduce, but when you add, values tend to what? Increase. So I'm going to plug in 5 here, then times what? When you add, you get what? 13. Now what do? In this case, I will say this belongs to this, and this belongs to this. Finally, we can equate the values. 3 to the power x minus x squared will be equal to 5, while 3 to the power x plus x squared will be equal to 13. So at this point, I'll have 3 raised to the power x minus x squared is equal to 5. And 3 raised to the power x plus x squared will be equal to 13. In order to get the value of x, what are we supposed to do? Then I'll set up one of the values, eliminate one in order to get the other value. So here, I will need to add up. So 3 to the power x plus 3 to the power x will give us what? 2 3 to the power x. That will be 2 bracket what? 3 to the power x. Then minus x squared plus x squared, they will cancel. Minus x squared plus x squared. Plus times plus is what? Plus. So minus x squared plus x squared is 0, nothing. So 5 plus 13 will give us what? 18. So I've got to divide both sides by coefficient of 3 to the power x over 2 over 2. Out. So 3 to the power x is equal to 18 divided by 2 will give us what? 9. So what do I do right here? I'll have 3 to the power x equal to, express this as 3 squared. That will be 3 raised to power 2. You know, when they have the same base, you equate the power. So what I have right here will be, finally, x is equal to 2. So that becomes the solution. Finally, we can run the check. If x is 2, then 9 raised to power x will be 9 raised to power 2. Then minus, remember x is 2, so x raised to power 4 means 2 raised to power 4. Can we get 65? 9 to the power 2 is what? 81. 9 squared is 81. 2 raised to power 4 is what? 2 times 2 times 2 times 2 times 2, which is what? 16. Of course, 81 minus 16 is what? 65. So the solution is correctly proven. Bye bye.